Okay, thank you, Elaine. So we have a slightly different format for our presentation. All four of us are going to give a quick lightning talk on a subject related to challenges in creating our cartographic database. So I have a team here, all of whom have been working on this project for several years. We're going to get into some of the individual issues we've tackled. But first, just a little bit of background on our cartographic database. National Geographic Society created version 1 in the early 2000s, and it was based on our atlas, our printed atlas that had been compiled over decades from paper sources. And it was great, sort of down to about 1 to 5 million. But even then, when we started using modern imagery-based references, we found that all that compiled line work no longer actually matched positionally. So shaded relief or imagery from modern sources no longer worked. So we had to tackle a cartographic database 2.0. And that's a project that I initiated in 2016 when I got to National Geographic. And the idea was to, in the first place and in the second version, to have this foundational database. And that it would work across all of our nonprofit and media properties so that the magazine could use it, the channels, and then all of our nonprofit work. And it was really great for Brooke to go before me because we have our own National Geographic map policy. State Department and US government sources are a key component, research component for us, but we establish our own decisions about this separately. It's not based on US foreign policy, it's based on a de facto status of the world and trying to represent that. And we wanted to make sure that's integrated into our database and into all of our map products, digital and print. And so it's really important for us to have our own version of a multi-scale map of the world. We didn't want to rely on Mapbox or OSM or Esri. We make our own decisions about how we're going to display things like place names, disputed areas, boundaries, and that needed to be integrated. So we have this core data. We weren't going to do everything. The core data for us is the hydrography, coastlines, rivers, lakes, boundaries, of course, geopolitical units, and then populated places. And that's been our focus. And another focus all along is that this is a cartographic database as well as a geospatial database. So it needed to work really well for cartography. So that's a little prelude. And we're going to have Sam talking about some of those data sources that we used. Nat's going to talk about compiling coastlines at a large scale, 1 to 200,000, which is a particular challenge. He'll talk about it. And then Daniel's going to be our harmonizer, talking about harmonizing data. And then I'll have a few last thoughts. So, Sam.
All right. Good morning, everybody. I get to start with the fun stuff, licensing and permissions. So very important for legal and ethical reasons. So this is just our situation here. We use 3 main types of categories of licenses or types of data. The first is data that was developed by National Geographic. So that's boundaries that conform to our map policy. It could be features that are derived from imagery or from other GIS analysis. We don't have to have a license or have permission to use that. Data licensed from other providers is another input. That was important for us with hydrology, where we couldn't get really large-scale, high-quality, large-scale drainage information. So we had to buy a contract from Garmin. So that's what we're using in our database. Lastly, we wanted to use open data wherever we could. So this is from a variety of licenses, and I'll talk about the different licenses that we used. So open is kind of a broad term. This was our requirement here. It had to be high quality and high resolution. We need to be able to do this at large scale. You can find a lot of open free data out there, but it's not necessarily large scale or high quality. We wanted it to be free, and beyond that, we wanted to not have any strings attached. So no contracts that we had to renew over time. And as Alex talked about, this is used by our media partners, books, atlases, magazines, so it has to be available for commercial use, which is a sticking point with a lot of data sources. So our gold standard is CC BY, which is a Creative Commons license that's applied to a lot of things. Basically, you're free to use and adapt the data as long as you give proper credit, and you can do that commercially. So these are the snapshot of the different types of licenses that we used. A lot of them were CC BY or CC BY SA, which is share alike. You have to be willing to share the data in a similar license. Some data sources did not have a specific named license. They just had a little blurb saying that it's freely available. Some said that you did have to give attribution. Some we got written permission in email form. Nat did a lot of this research, and so he was emailing people, and we have emails from various government agencies saying, yes, you're allowed to use this data. So we keep that for posterity. Some of them didn't have licenses at all, and so we do our best to see whether that was intentional or not. That could entail reaching out to an agency and seeing whether they had forgotten to put it out there or whether they really just put it up for free use. And then there are also specific named branded licenses for some countries, I'll show you one in a second, that are functionally similar to CC BY, and so we could use those. Down at the bottom, there's a list of our sources. We'll share the slide deck, and you can go check those out if you're interested. So just a few examples. Ecuador uses CC BY. They just slap it on there. Good to go. France has a specific branded license. They even have a really cool logo. And if you speak French, you can just read their license description. If not, you translate the PDF and realize that it's functionally equivalent to CC BY, and then you can go ahead and use that. That's all I've got. I'm going to pass it off to Nat.
So, in 2018, Hans van der Marl, Daniel Huffman, and I worked on the original coastline iteration for this project. We started with NGA prototype coastline for areas more or less south of 60 degrees north, not including Antarctica. We edited that heavily. Hans did a whole bunch of generalization and rounding work for it. And then Daniel and I did various bits of editing, adding, and so forth. And particularly in the Arctic, since we didn't have anything above there, we cobbled together from a number of different sources and did a surprising amount of manually traced satellite imagery for northeastern Greenland, Canadian islands, and Franz Josef Land. We're all just like, there's nothing that's good enough, so we traced that pretty much entirely. There was one big problem that we didn't address at the time, and that's that the NGA data is on a high tide line. So tidal salt marshes and mangrove forests are shown as open water. Here are the Sundarbans in India and Bangladesh with the original coastline. You can see there in orange. So in 2021, we redrew the non-Arctic coastline using a relatively new database, the Global Island Explorer data from the U.S. Geological Survey and ESRI, which uses a low tide baseline. We didn't want to undo all the work we'd done, so basically what we did is we took our original 2018 file and this new file. Jonathan Weiss of Topaz Mapping developed an algorithm to crop whenever it crossed on larger land areas, and for smaller islands to look at choose which island was probably better. And we had a fairly complex algorithm to decide which island and which coastline would be used as our default. It was pretty good, but I still went through the whole global coastline south of 60 degrees looking at it against satellite imagery, basically saying which line, does this look close enough at 1 to 250? Good. No, okay, we'll switch that then. And examining places in particular where inlets and estuaries that we had on our database might also be salt marshes or open water. This is the area around Atlantic City, New Jersey. So the original processing of the NGA data had included a lot of what I'll call punching and stoppering issues. The original data in red in this animation included a lot of bridges as land. So I went through in the initial iteration and looked to distinguish causeways, which we kept because they're land, from bridges, which were punched out of the data, making islands islands. And the results of that are the orange in this animation. Is the animation showing up? Yeah. Okay. And we also had issues in that often rivers were shown going way further inland than we wanted. For NG's distinctive cartography, which includes the color bands around the coastline, basically the coastline is where the color band ends. So I was making a judgment of, okay, how far do I want it to go in if I were deciding where the color band ends. So we're stoppering up estuaries and rivers on that database. So that's that. And then we also added salt marsh areas to land areas as part of this process based on the new USGS Esri data. Other issues emerged. It turns out that the NGA data, which was developed around 2000, was shifted in some areas in relatively high latitudes, which shows up especially in smaller islands, which start looking like this, like a 3D glasses picture. The Alaskan archipelago, southern Chile, and here in Åland off of Finland, you can see, I hope you can see that there's enough of a difference between the orange, which is the old, and the blue, which is the new. We simply wiped all the old orange out when it looked this bad and subbed in the blue in these areas. This data is temporary. We know that. The original NGA data in red here, in the Yellow Sea area off of China, was based off of 2000 vintage imagery. And the current updated data in blue reflects both the low water, you can see a little bit of an area in the southwest where there's a difference, and the vast construction works for aquaculture and shipping platforms shown here. This is probably the most dramatic place on Earth, but all over the world, particularly in Asia, but really everywhere, there's been this enormous change because of aquaculture and because of building large shipping pier platforms. Well, this image is at the mouth of the Mississippi, and you can see both the 2018 lines in orange and the new lines in blue. You can see both the areas in the north, where the replacement of high tide with low tide lines makes a significant difference. It fills in land. And in the southeast, where erosion has wiped away land. We're going to lose a lot more land in the coming years, and presumably we'll also see constructed responses to that loss. There are a few places, notably the Gulf of Bothnia and Iceland, where we're still gaining land because of millennia of isostatic post-glacial rebound. And that continues, but glacial tongues all over the Arctic are retreating past the tide line, and what ice shelves there remain will only remain so long, and eventually will start creeping up as ocean rise kicks in. Especially in the areas with low-lying coastal land, the future is precarious, and we'll be needing to update this base way too soon.
Okay, we're running low on time, so I'm going to be real quick here. I've been working with the hydrography data. I've been working on giving it some cartographic niceties and harmonizing it with that cartographic database one, which we internally call the legacy data. That involves going through and looking at these things and saying, which of these lines lines up with these other lines? Should I transfer the data from this one or that? And it can be kind of a slow and painstaking process, but it's worth it because there's all this experience that Alex has mentioned in building these scale rankings into the data based on looking at all the old atlases and all the decisions that have been made over decades. So we want to make sure that we pull that experience into into the products that we're producing so that these things harmonize. In the new Garmin data harmonizes with all of the existing products. And also I lined some other lines up with some other lines, and that's all I got time to say about that, so we'll just pass you on. Okay.
Thank you for your brevity, Daniel. Critical work, harmonizing data, topology matters. as do gratuitous photos from the National Geographic collection. Just a quick point that our database is a system of record as well as a system of production. So our map policy as it changes, our coastlines as they change, we want a record of all of that. So this is a system of record for our database. And just last thought about the complementarity of the data that we're working on. Obviously people are using natural Earth at scales from 1 to 110 million to 1 to 10 million, and I know somebody's going to be talking about that later. Our goal, and we're going to be working with our legal department on this, is a downsampled version of our data that we can release. And it will be complementary to natural Earth at a larger scale, at 1 to 2 million, maybe 1 to 1.5 million sort of scale. And that'll be just some of the feature layers that we feel like are fine to, and our legal team allows us to release, something like the coastline for sure, that we'll be able to share with people. So this has been a big project. This is only part of the team. There's folks at National Geographic, Ted Sickley, Martin Gamache, Zoe Lieb, Yanli Gong, Justin Myers, our newest member of our team, Scott here in the front row, and as Nat said, there's other contractors that have helped us on this. So thank you very much. It was great to talk to you.